As I edit this video, I brought it down from 3 hours down to 1 hour. Not bad. This is a long video, so I'm going to make it easy for those of you who don't want to see the whole video. And we're going to go ahead and take a look at the finished product. There it is. This is the 1949 GE Vortalex. This is a 12-inch desk model. I narrowed it down to a 1949 model year based on some information from dtvintagefans.org. .org or .com. And what makes it a 1949 is, number one, the mist gray color, the red head badge, and the model number, the FM12V41. All of those things put together equals 1949. It also has a carrying handle mounted to the motor, where later models had it mounted to the grill. This fan was it was an antique store find, and I was surprised at how reasonably priced it was, which is why I bought it. It was only $35 after he took 10% off the original price. I had to bargain him down to that. It was originally, I don't know what, actually I never did figure out the percentage, but it was originally marked at something in the $40 range, whatever. So add 10% to whatever that. Anyway. What I liked about it at first was the fact that it had all the original paint. It was obviously never serviced, which is good and bad. Number one, it's good because it was never serviced improperly. But number two, there could be excessive wear, so I was really gambling with my money at that price. I looked at the condition of the head wire, and it was still intact. Original head wire was still in good condition, no fraying of any kind. It had the original switch, which is pretty rare on these. Oftentimes these switches have been replaced multiple times throughout the years. The original power cord was in terrible shape, as you're going to see in the next scene. We'll take a look at that, what it looked like when I got it. The paint, other than being intact, it was covered in filth. It was covered in basically dried up grease and oil that had spilled or somehow misted onto it. The blades were bent, and when I went to go power it up in the store, I noticed that it did vibrate excessively. In fact, it was jumping around the counter. It was pretty bad. The blades were bent, and someone had previously tried to straighten them with a pair of pliers, and did a very, very disservice to the overall blade profile. But the grill was bent. I mean, it was all the damage from its previous fall was still there. You know, it was worse for the wear, but I saw potential in it. You know, I was looking at instantly. I figured out, okay, replace the main cord. Number one. Number two, refelt the base. It had the original felt on it, and it was in pretty rough shape, as you will see in just a few moments. The motor was not seized up, but it was stiff. Obviously, it had not had any service to the bearings ever, and I took the oil cup off, and it was filled with sludge. It was, and of course, knowing what I know about these old GEs, I know what lies in this gearbox. It was filled with like a crusty, ambered oil. It was like a fossilized grease. It was disgusting. But again, I saw potential in this fan, and I'm glad I picked it up, because this is what the end result is, as you can clearly see. When you see what it looked like and sounded like before, you will absolutely appreciate what's been done. Now, this video is somewhat instructional. The methods that I use work for me. It may not work for you, and there are other people who may scoff at my methods, but I have perfected what I know over the course of the past 20 years. I've occasionally bought and restored antique fans. This was not intended to be a restoration. This was intended to make this fan functional again so that I can use it. I only buy antique fans when I have a use for them. Sometimes I'll buy them on a whim, but generally I buy them to use them, not to display them or to sell them. The thing is, these old fans work better than anything made today, and they'll last longer than anything made today. This fan will outlast every Dyson ever made. I mean, it just will. And because it was built simple, it was built to last, and it was built with some semblance of pride. Now let's hear it run. I'm going to start it up on low speed, and then we'll work our way up to speed number 3. I'm very glad to have gotten the vibration out of the... It does vibrate a little bit, but not like it was. And I'm glad that I was able to get rid of the coil buzz from the motor by epoxying, and we'll go over that in the video as well, but all 4 coils had to be epoxied in place. They were all loose, which was causing them to buzz. But it sounds beautiful. It sounds clean. It sounds, I don't hear any vibration or rattling. I hear some noise caused by the airflow across my desk, but that's neither here nor there. Why a Vortalex? Why would anyone favor the Vortalex over anything else? The Vortalex was one of GE's, I wouldn't say it's one of their better products in the company's history. The Vortalex was a fan that was built in a time when fans were necessary. It was built before air conditioning was as prevalent as it is today, especially in the north. And it was built, it was actually designed pre-war. Actually, I think the first Vortalexes came out in the mid-1930s. And it was a product that GE produced up until the early 1960s. And the Vortalex was a quiet blade design on a typical GE platform. Okay, so the Vortalex Vortalex fans always have these overlapping quiet blades. Some are 3 blades, some are 4. The motor itself isn't unique to the Vortalex. It was used on other GE products. And the motor design and the gearbox date back to the almost to the AOU days, back in the mid-19-teens. As a matter of fact, this gearbox is identical internally to the gearbox that was in my 1918 AOU fan, which is the old loop handle models with brass blades. It's an old design, but it's a reliable design. And GE produced them until the costs became too high, and they decided to produce them, using more plastics and more stamped steel. Now, as far as the collectability of these, the Vortalexes are extremely collectible. They're getting valuable these days. I'm finding that this particular fan, I found one for around $125 on eBay. And it's more than I would ever spend on a fan, but hey, that's why I always buy the ones that need work. I get them cheap and I fix them, and I usually have good luck with them. This is going to be used as, I personally like to sleep with wind blowing in my face. It's just something it's always been a thing for me. So I try to find good quality, reliable antique fans to do the job. And so that's what this is going to be used for. What's unique about this fan that I noticed pretty quickly is this tag here. It says Res Lab A68. I imagine that's short for Research Lab. It's hard to say where this fan came from, but I think it either came from a college or a corporation nearby that does research. It's hard to say. This is the greater Boston area, so it could have come from really anywhere in the region. So, I mean, it was probably purchased at an auction, an estate auction or something like that. But it definitely had it was definitely well used in its day. and it was cared for. It wasn't beaten up. It was dropped once or twice, but that's to be expected. So for those of you who want to continue to watch and see how all this went down, what was done, and how involved it was, I encourage you to stick around and maybe learn something, maybe not, maybe maybe trash me in the comments boxes. I don't care. As long as we have fun, right? So without further ado, let's move on to the repair. First, we're going to see the fan as it was being inspected, as I was starting to look it over to see what it would need. And then we're going to go on to all the various repairs it needed. And I tried to make it as instructional as possible. So I'm going to shut up now and let me do the talking afterwards. Thanks. Just picked this up today. This is an old GE Vortalex. This is real deal. Original finish. And yeah, it needs work. The motor is a little stiff. I got the guy down to $35 is what I paid for it. The cord is munged. It's got the original switch though, which is kind of nice. Even the original plug is smashed, so I mean I'm not going to reuse that. But it's overall in pretty good condition. The blade is, or the cage is on wrong, although I'm not really sure. I'll have to play with it and see what position it works best in, but definitely on wrong. One of the things I like about it, though, is it has an original ID tag from wherever it came from originally. It's ResLab A68. So it probably came out of a college, perhaps, or something like that. It's got the original. Now, it's amazing that this is still here because it's not attached to anything. It just rests there. So it's kind of a shock that didn't get lost. But it's a 4-blade. It's been through hell and back. I mean, look at this blade. It's just in sorry shape. Looks like it got hit by something. Actually, you know what? It looks like somebody took a pair of vice grips. It looks like it may have been dropped, actually. And somebody tried to straighten the blade out with vice grips. But I'm not worried about any of that because this isn't getting restored. It's getting repaired. And I'm going to use it at work. So anyway, it does turn on. The motor is pretty much gummed to hell, so we're going to have to put it on its 3rd speed. The switch, by the way, works really well. And we're going to watch it spin up to its death. Ooh, it's off balance. Oh boy. It's really off balance. Oh shit. Looks like it might even have a bent shaft. That's not good. Well, we're going to have to fix it somehow. If I can. Yeah, that's not a good thing. Let's take the blade off and see if the shaft is bent, because I think it is. But the switch is good. It works on all speeds, including off. Alright, let's get this thing apart, because this does not look good. And then we're going to tear the motor apart, and we're going to clean all the grease and dried oil off the shaft and re-lubricate everything. Let's take a look at this wick. Now this is an oil cup with a wick. Oh boy, that's never been cleaned. Now you can save these wicks just by trimming the end off. Once you clean them out, well, this one might have to be replaced. I think what I'm going to do is I'm going to order a wick kit for this fan, because this one is so gummed up I don't think I can save it. So we're going to get a new wick for it. I'm going to buy a new cord. You can actually buy now I just want to point this out too. This is important. This Vortalex did not ship from the factory with a cloth cord. Now I'm going to take a look at the age of this. You can actually find out how old any Vortalex is by cross-referencing it There's a Vortalex fan site on there somewhere. Get it? Fan site? That will tell you how to identify the age of any Vortalex based on color, size, and other options. Now this is the original cord. It was not originally a cloth cord. Just because a fan is old does not mean it would have come with a cloth cord. That's the important takeaway here. Important word of caution when taking these apart, and I almost did this to myself, these are reverse threaded. So the oil wick has to come off, and we're going to take the front of the motor cover off as well. We're going to pull the the armature out. Yeah, that's good. Now you can see what's going on. But be careful that we don't tug the head wire too much. I want to use that wire again. It's original, and I want to keep it. We've got a broken spacer here, a fiber washer. Make sure it's unplugged, by the way, just for obvious reasons. We're going to angle it down a little bit to take some of the stress off that head wire. Try to be gentle with these fiber washers because you know they're reusable as long as you don't break them. So just be careful. There we go. Unfortunately, with this particular fan, you have to disconnect the head wire to get everything out, to clean it. And we're going to take the top of the gearbox off. Can you see what I'm doing? Yeah, you probably can. We'll take the top of the gearbox off. You never want to take an antique fan like this, just plug it in and enjoy it. It's not one of those appliances you can just do that. You have to take care of some very, very pressing maintenance issues. Here's the gearbox cover, and this gem right here serves a couple of purposes. This is what you thread down to engage it, and this is what you thread up to lock it in place. I want to show you just how impacted this grease is. Now, if you're thinking that you're going to just run the fan the way it is, here's why it's such a bad idea. Take a look at this. This used to be grease. It's now basically amber. It has no viscosity to it. It just gets, what happens to this stuff is it moves out of the way and stays there. It never flows around like it's supposed to. So nothing in here is getting lubricated. If this fan was run like this for any length of time, eventually the gears would simply strip out. But yeah, we got to take all this grease has to come out, and you don't want to use. You can use some parts cleaners. So if you take the gearbox off, it actually unscrews from behind the rotor, which isn't coming out. Usually they just slide right out. I'm going to nudge it from the back a little bit. There we go. There we go. So here's the rotor. And here's the bearings, or this is a surface that rubs against the bronze bushings. The front bushing and the rear bushing is on the other side. Oh. Mind these washers. These were placed in there at the factory, and they are in specific locations for a reason. These little fiber washers do not... Make a mental note of where they go, that's all. And looks like this one is in pretty good shape. I don't see a lot of excessive wear on the shaft, which is a good thing. I'm going to go and clean this up real quick. I'm going to use brake cleaner to clean the shaft because I have brake cleaner and it works. And I'm also going to take the front bearing out, and I'm going to clean that too. And what the hell, I'm going to take the gearbox off, and we're going to have to tear it apart. I don't think we have much choice. It's got to be done. At least we'll get the motor running correctly, and then we'll dig around the blade and get it doing its thing. I'm also going to, because I don't have another wick in the house, I'm going to just take this apart and I'm going to clean it out too. It is unpainted, so I don't know. Oh yeah, I was getting to that. You don't want to just use brake cleaner on all this stuff because it will eat the paint right off. If you want to preserve the original paint, brake cleaner is not your friend. But there are parts cleaners that can do the job without ruining the finish any more than it already is. Now, if you want to get the counter shaft out, it's really easy to do. This bearing, or this gear right here, is held in by this cap. Now this cap is held in by a set screw. Very important to try to not, it's not like you can stick a screwdriver on this cap and it all comes apart, and that's not how it works. You got to take a small flat blade and relieve the tension using this set screw. Now this is common, by the way, to all General Electric fans into the 1960s. The oldest fan that I've ever seen that had this design, and again, when General Electric designed something, they just stuck with it. They're really good about that. But now that we've relieved the tension on that, so yes, it is threaded in, but that set screw is what locks it down. Yeah, this design dates back to the 19-teens, and the oldest one I've ever worked on was from 1917, and it was very similar. Now, once you get that cap out, that end cap, this will slide out of its mount. You can tilt it up and pull it out like that. Now we're going to clean that part too. That all has to be cleaned really well. And you can get the rest of this grease just by picking it out with a screwdriver if you wish. We can use WD-40 to get all that out of there. WD-40 will break it up. In fact, I think that's what I'm going to do. Why don't we do that? We're going to get some, I'm going to get my other screwdriver, my smaller one. So I'm going to just take this out. Got all that done. So here's the gearbox completely removed. There is one fiber gear or fiber washer here that is completely destroyed, and that has to come out. So we've got to come up with some new fiber washers because that shaft is going to have too much play. So we're getting there. I did take out the clutch gear, and it looks like in this model year they started using fiber. Originally, these were made out of brass. I think all of the Vortalexes had fiber gears, and this is basically a sacrificial component if something were to go wrong and the fan were to oscillate itself into something. This will wear out, and it can be replaced. This one is still good. It has all its teeth. It has some wear, but it's not bad enough to be a problem. I'm going to try to clean that up as best I can. I'm going to have to use a toothbrush. Just going to clean it with a rag here. Now, I want to point this out too. So the counter shaft, this piece here, which yes, there's a gear in there somewhere. There's a worm gear and another fiber gear on this shaft. That rides inside this bearing right where I'm aiming the camera. There's a hole on top. Now that hole is supposed to allow some of the oil and the grease to absorb into that bronze bushing. But you can clearly see it is completely plugged up with dried up grease, which is bad. So again, if you want to run this thing in your dorm room because, you know, it's cool, that's wonderful, but just understand that if you don't fix it correctly, you're going to have big problems. So we've gotten most everything clean. One thing I like to do is, now I didn't use the brake cleaner on anything because it really didn't work very well. I know I've used it on other projects, but I think it was an older style brake cleaner that a little more hazardous. It worked better. But this time, not so much. One of the things I like to do is I like to polish both sides of the armature shaft with steel wool. This is quadruple zero grade steel wool. And this will make sure that any varnishing or anything left over from the old days, old lubrication, what have you, is basically polished off the shaft. And it also ensures that the shaft will enter the bearings more cleanly. So this is always good to do. Remember, when you take the washers off the shaft, you want to make note of where they go. That is very important, because even though we're down 2 washers, I'm going to try to assemble it and see how it goes. I may not have to worry so much about excessive end play, but if I do, you know, I'll just order some new washers. So the shaft is good and clean. The armature is ready to go back in. I've got to figure out a good way to clean the paint so that it doesn't ruin the finish. I'm thinking I'm going to try a little bit of WD-40 and some light brushing with the steel wool to get some of that baked on crap that's on it. It seems to be working okay. And then maybe throw a coat of wax over that as well. But right in the back of the motor housing, it's really, really crusty. Oh yeah, that's working nicely. Taking it right off. Hopefully not taking off too much of the paint, because that would just, you know, suck. But they used to use really high quality enamel back in the day, and it could take some abuse before it started scratching and going off color. But this is really working well. I'm going to just keep doing that. Yeah, let's see how that looks after it dries. Probably going to be the worst thing I ever did to it. Okay, so now we're ready to start reassembling. Now the clutch, we need that. This. Now the whole purpose of this assembly is to basically allow this gear to freewheel until this washer is clamped down against the gear and the shaft, making it one unit. Here's that washer goes on like that, and this drops in. We've already cleaned out the bearing. And before we reassemble it, we're going to put a few drops of oil down in here. Now, in older versions of the Vortalex, this is an oil port, and for whatever reason, GE decided that it didn't need an oil port. So we're going to have to load that bearing up with oil. I'll clean up this other washer. This goes on the other end of that shaft. And then this is that little bearing cap, and that gets threaded back in. And you want a slight preload on this shaft. It's a very slight preload, nothing serious. You want it snug, but not snug so that the shaft has to be able to freely rotate, which it can at this point, with a little bit of side-to-side play. You don't want it too tight. Make it a little more. There we go. That should be enough. Then we're going to take our screwdriver and we're going to retighten on that set screw. That keeps everything from shifting around. Now we're ready to pack that sucker full of grease. But first we're going to put the armature back in. I'm going to get my oil. I want to make sure I pre-lube all those bushings before I forget. And this is what you want to use. This is a 3-in-1 SAE 20 oil. This is for small machines, motors, fans, etc. Good stuff. We're going to put some oil down in that bearing port. We're going to put some oil down in there. We're going to oil that right there. Just get everything pre-lubricated so that we don't have any problems. Okay. There is no washer on the end of the motor shaft. That's how it came apart. That's how it'll go back together. Okay. Boom. Oopsies. Let's get this. Ooh, careful. Okay, when it comes to packing it with grease, this is actually kind of important. You do not want to use lithium grease, white lithium grease. I've done this before. I made that mistake. Don't do that. You want to use regular bearing grease, wheel bearing grease. I would use, if you have one, a popsicle stick. And you can just pack it really tightly in there. Yeah, this is not a place where you want to save the trees or whatever the hell it is kids these days try to do. You want to really pack this freaking thing nice and tight. And what's going to happen is some of it's going to leak out initially, and yeah, that's going to happen. So deal with it. Now, when putting the covers back on these Vortalexes, because these cover screws, well, this isn't, well, alright. On this Vortalex, on this model, these 4 screws in the back do not hold the rear cover on because there is no rear cover. The rear cover is actually, basically, this entire motor housing is stamped from one piece of metal. What these screws do is they hold the stator in place. So, the way this motor housing is designed, you've got these punched impressions in here. There's 1, 2, 3, 4, 5, 6, 7, 8 punched impressions. What they do is they hold the stator back. So if you're reassembling one of these, make sure that you tighten the rear 4 screws in sequence They have to be torqued in sequence. So 1, 2, 3, 4, or whatever. It's 1, 2, 3, 4 until they're all nice and tight. Then you install the front cover. If you install the front cover first, as you're torquing the front cover, the stator will move forward, and you don't want that. So let's go ahead and torque down the front cover. We've already torqued down the rear 4 screws. Now it's time for the front. Camera's at a bit of a precarious angle. I apologize. Okay. Now, this particular stator cover, or motor cover, it seats into a lip, and you want to make sure that it is fully seated into that lip and that it is on straight. You can tell that it's on straight once you start threading in your first screw. In fact, if you really want to be technical, take a screwdriver, and if you can't put that screwdriver into that hole all the way, then you know your cover's on crooked. So I don't see an alignment punch or an alignment mark on here, so we're going to have to find it ourselves. I'm going to shine a light through here and just rotate the cover until, yeah, there we go, until I can see the screw holes. Sometimes you're lucky, sometimes you're going to find there's an alignment mark or something, but there isn't on this model for whatever reason. Rotate it. There we go. I think we're almost in. Now these are... Okay, so the wick needs to be replaced. There's a section right in the middle of this. If the wick is completely soft and you can flex it and you can squeeze it and oil comes out and it's looking good, that's fine. But this one has a section in the middle where it's hard as a rock. So in order for this wick to function, it has to be able to, using capillary action, suck the oil up from the canister and draw it right through where it will then deposit onto the motor. But unfortunately, it can no longer do that effectively. I'm going to put it back in again just to get the fan running, but I'm going to be ordering a new wick for it, and I might order a set of wicks for that one. That one actually has a front and rear oil cup. This one only has one on the front. Okay, so we've got this back together. I cleaned up the finish a little bit more, and it's looking a lot better. I just think it's great that the original finish on this fan is somewhat salvageable. Whoa. Lock the oscillator in place. And it's got some wobble. And that is purely because I really wish I could find a new blade for this, because I think I can fix it though. Spinning fast enough, it stays straight. Boy, does it move air. Wow. Yeah. So the issue is caused so we're going to have to figure that out. I'm going to show you a nifty way to determine if the shaft is bent. Turn the fan on to high speed. Take a ruler, wooden, and just rest it on the shaft. Listen and feel for the vibrations. If the blade is bad enough, this ruler will be bouncing pretty badly. But I'm feeling the only vibrations I'm feeling are the vibrations of the motor itself. Then move it towards the tip. Oop. And it should feel roughly the same as it did in the inner part. Remember, a bent shaft will be worse at the tip than at the very beginning. You can even use your finger. Okay, so after about an hour's worth of tweaking and checking reference measurements and just examining the blade as it spins, I've gotten the wobble out of it. And really, there was no need for silly putty. This stuff, I mean, it was kind of wasted my time when I should have been focusing on pitch and reference points from the wingtips to a reference point on the reference measurements. I beg your pardon. From the tips to the handle, or any spot on the motor housing that I could use as a reference point, and I got the wobble out of it. Now that's to a respectable level, and I'm going to leave it alone. It's good enough so that the fan no longer walks across the counter. Let's turn it on, starting on low. Observe. There's a little bit of shaking, but it's an acceptable amount. Now let's ramp it up. Finally to max speed. No more shaking, no more wobble, no more fuss, no more muss. Let's turn the oscillator on and see how she goes. So we just took this, she blows, baby. We just took this $35 thrift store / antique shop find and we made it great again. So this base is held on. Oh yeah, we're gonna refelt it too. Let's just take the felt off. I'm gonna totally refelt it anyway. So I think I have some green felt left over from another project I can use. So, or I'll pick some up tomorrow. I meant to do that today, and it totally spaced my mind here. So these rivets can be easily pulled using a flat blade screwdriver. You just open them up or close them up very carefully, and I'm going to do that. See if I can put the camera someplace safe. You can see me work my tricks here. The older Vortalexes obviously used screws, and we're going to reuse these rivets. These are still good. Actually, I think you can just push them out like this. Yeah, that's how you. That's one way to do it. That way we don't mess up the baits too much. And then you can just pull them out. Like so. And again, they are reusable up to one time. I think after that they'll start to fatigue, fail, and then you'll be replacing those suckers. So all those rivets, we can save them, we can reuse them once, and then of course fatigue, failure will set in. You want to do this with the cover, or with the blade set with the what's it removed. The grill, thank you. The grill removed. Now check this out. Now this is, I see what looks like heat shrink tubing, but it's not. You can see the where the wiring meets the old cloth wiring. This is some old shit right here. This is some old shit. Look at these old-fashioned 1940s crimp-ons. Look at that. Pretty simple. The switch in this thing is original and still good. We're just going to tighten up the tighten it up a little bit. Okay, so what do we do on BBISHOPPCM's world with electrical connections? Every time, no exceptions, we solder and heat shrink tube them. I do this because it is a permanent installation. It'll last longer. It'll never fail. There's nothing to loosen up. I have had a lot of times some of the cheaper quality crimp connectors will fail, or they'll loosen up or something, and I just don't like them. I don't like crimp-on connectors. I think they're cheap and half-assed. They have their place, and antique electronics and fans is not one of them. Polarity doesn't matter here because the original plug is not even polarized. But we don't have a lot of wire to work with. We really can't make a lot of mistakes here. We have one shot of getting this right. Okay, so about that grommet. With enough persistence, with enough positive attitude, and you stuff that motherfucker right in the hole where it don't belong, you'll be good to go. So that grommet is now installed. All right. Okay. So we got the grommet in there, so I don't have to go back to the store, at least not right now. I can do the wiring tomorrow. I got to get some felt tomorrow after work, and I'll do that. And the felt will allow me to cover the base. I just checked upstairs. I don't have any felt. Thought I might have had some from a sewing project, but turns out I don't. So now we're going to run the wire in. We're going to make sure that there's enough room for a nice strain relief knot. There we go. And that way everything can be hunky-dory and dory-hunky. Alright, so I've already went and stripped back the insulation on the lead-in wires, and one of the things you're going to find as you work on some of these old items is these loose fibers can get in your way. Just singe them off. Of course, you want to make sure you've got some water handy in case things go, you know, south. But when you're soldering, they get in the way and they make for a really messy and weak connection. Alright. I'm going to go and split our wires apart, strip them back. Like so. We've got our hot iron ready, we've got solder ready, we've got heat shrink tubing. Now you want to spread these wires apart enough to give you room to drop the heat shrink tubing down away from the solder joint. Why? Because, well, the heat is enough to ruin your day. I'm going to cut off two ample sections. Actually, I'm going to use the two longer ones there and trim this one down. I'm going to use two sections of heat shrink tubing. We're going to drop it down the wire like that, away from the heat source. Remember, folks, don't forget the tubing. Sometimes when you're rushing, you're getting things done, and you forget. Now, I don't have enough strip back on this lead here, so I'm going to strip a little more of that back, nor do I have enough on this one. So I want to, again, just be real careful not to snip anything, because it's real easy to... This old gutta percha wire sometimes can be a challenge to work with. Just a necessary evil, unfortunately, when you're you know, a baller like me. So they didn't give me a lot of wire to work with, but it's enough. No, I'm going to need more. Definitely I'm going to need a little bit more, because I want to make sure that I can twist these wires together firmly. Yeah, this stuff is a pain in the ass. It really is. I can't imagine it was much better when it was new either. You know, it's just that difficult. So, especially when you don't have a lot to work with anyway. So we're going to twist this good and tight. I'm going to throw down a bead of solder on that. I'm using 60-40 leaded solder because the stuff is just that much easier to work with. So So we're going to preheat it a little bit. We're going to lay down some nice solder. Give it enough time to heat up there. This is rosin core, by the way, in case you're wondering. You want that solder to wick its way down the wire. And there you go. Yeah, that's a nice, good connection. And I'm going to trim the tip off of this, because sometimes that tip you know what, it's not too bad. But sometimes when you're left with a bit of a chimney, it can poke through your make sure that's nice and flattened. There we go. It can poke through the heat shrink tubing on occasion, and you're going to have a bad time. All right. Let's make sure our heat shrink tubing can fit through that. Yeah, that's a good connection. That's a good connection. I can tell. There we go. And just one of the problems when you're working with this old wiring is that occasionally loose frayed cotton they didn't use rayon back then, they used cotton. It can get pushed back as you're trying to slide your heat shrink tubing down it, and yeah, it just makes for a nice mess. Come on now, get in there, you. There we go, we're good. Sometimes twisting the heat shrink around it can help work it on. Okay, now we're on to our red wire. Now this one's going to be a little easier. I have a little more wire to work with. It's a little friendlier to me. Get it nice and tight. And we're going to get our solder. Yes, you can use mechanical connections for this. You can. I choose not to. I don't intend on taking this apart again. That's the plan. Okay. Ooh. Remember, heat conducts through copper really well. And I'm going to have to clean the tip off with a wet sponge because I got some slag on there. Like I was saying, you know, that old cotton insulation can really mess up your day. Sometimes even a small amount of it can get into the connection. Yeah, this is not a good connection. This one is being difficult. Right. What can we do about that? Is it good? Let me test it. I'm going to do a quick mechanical test. No, I'm not very happy with that. I'm going to have to redo the whole thing. Just this one though. Add more solder. Oh, it's working. It's good. It's good. I cleaned it right up. Perfect. Okay. Now, again, clean the solder tip. Always, you know, if you don't have one of those fancy mesh balls, a wet kitchen sponge is actually usually what's included in most beginners' soldering kits, and they work very well. Always use a wet kitchen sponge. Okay, we're done soldering. I'm just going to unplug my iron here. Alright, I'm going to slip my heat shrink tubing in place. Cover up that ugly mess I just made. We could use a heat gun or fire. Heat gun would be preferred, but I don't have one handy, so try not to get anywhere near your cloth wiring because you can set it on fire, and well, that would be bad. So there we go. Good. Connection is complete, and that is what it's going to look like when it's done. And it's still warm, so it's still a bit sticky. That's fine. So that's just going to sit right back in there, and it'll be good. Listen to spin right up. And that oil cup is full of oil, so off, low, and high. Okay, it looks like there's going to be more than enough room around the perimeter to allow me to fold the felt over this piece of it's like masonite or something. It's not asbestos or anything harmful. It's like it's almost like a cardboard. Like, I think this is the same stuff they used to make acoustic ceiling tiles out of. Interesting. Alright, so let's get started on that. I'm going to use some Super 77 adhesive. And $10 at Hobby Lobby for this little can. I think I overpaid. Anyway, I'm going to bring it outside. We're going to coat this board with felt. I mean with glue. We're going to get it nice and thick on there. And I don't want to dig into this too much, so I'm not going to try to get the rest of this off. It's really just it's really negligible at this point. So we're going to do that. I'm going to cut a piece of felt that'll fit around it. It'll be fun. Okay, we're going to coat both the back side of this disc as well as the back side of the felt with spray adhesive, which we've already done, and apply it. And we're going to let that dry for a little bit, but we're also going to take our cutting board and a fresh razor blade, and we're going to cut slits about the thickness, about 1/4 of an inch or so away from the edge of the disc. And we're going to cut slits all the way around, probably about an inch or two apart. And wait till you see what we do with those. So what we've done here is we've taken advantage. We're going to put a little smattering of glue on there, but what we're doing is we're going to cut like that, about a quarter of an inch away, cut out, and do that all the way around in 1 to 2 inch segments. Then we're going to fold them over and glue them down. So I'm going to pre-spray. I'm going to cut everything first, and then I'm going to spray it, and then I'm going to fold it, and it'll come out looking really cool. So I've gone ahead and I've cut all of my relief slits, and I have sprayed some additional tacky glue. I'm just going to fold it over like that. Obviously the relief slits are what prevent this material from kind of bunching up. And I'm going to do this. Some of these got stuck together a little bit. Now this stuff really dries and sets very quickly, so you don't have a lot of time to work with it. You kind of have to just sort of have a plan of action and just go for it. And there you go. And that, oops. If you make a mistake, you can loosen it up a little bit and then re-pull. Now this is how I did the base on my my 16-inch Vortalex. Only difference is that had a metal base. And we're going to kind of look at the edge of this disc and make sure that everything is nice and tight. Looks pretty good. I'm pretty happy with this. And that's it. Once that dries, I'm going to give it about an hour or so to dry. We're going to start putting it back together again. To make this easier to film, I've marked off where the rivet holes are. There's one here, here, and here. And I'm going to take some pliers. I'm just going to close them up a little bit. Hopefully they don't break. That's, you know, a very real possibility. So now what we're doing is we're putting the rivets in place without the proper tools. Not everybody owns the proper tools for these types of rivets, and I'm certainly one of them. So what I'm doing here is I've already done one rivet. Now we're going to do our second, which is going to be right here. I'm closing the rivet up. I'm closing the rivet up as much as I can within reason, using my pliers. Okay. Then I'm going to poke that rivet right through the hole. I'm going to take a Phillips head screwdriver, and I'm going to try to get the screwdriver tip so that it kind of straddles the rivet like this. This is not the right way to do any of this, but this is what you do when you don't have the right tools. You improvise. Figure out a way to make it work. I think I'm going to open it up a little more with my Phillips, or my flat blade. Try to figure out where there we go. So we got it now locked into the rivet, so I'm going to push. There we go. I'm going to open it up a little bit. I'm going to take my Phillips and use that to kind of press the rivet open. I need better. So what you want to do is get the rivet so that it starts to split apart. And then when it least expects it, I'm going to try to use my channel locks to do this. Might be a better idea. There we go. Crush it down. Perfect. Perfect, perfect. You know what, I'm gonna use this for the other one too. Oh yeah, that's much better. As a matter of fact, that double layer of felt may be redundant at this point. Yeah, I think so. I don't think I need it now. I've got these rivets crushed down so that they're well beneath the surface and won't give me any trouble. If that cover ever needs to be removed again, I will have to replace all 3 rivets. They will not take another pounding like this. I'm fairly certain. Yeah, get that nice and crushed. There we go. Okay, for the final assembly, I'll put the blade on first. Get it nice and torqued down. Okay. Before I do anything else, I want to make sure that this fan doesn't bounce all over the place when I run it at full speed. Because I can still tweak the blade a little bit if I need to. I don't have the cover on yet, or the shroud, if you want to call it that. Everything is nice and exposed. So let's see what happens. Starts to bounce all over the place, and I have more work to do, and I don't want to do that kind of work right now. There's a little bit of coil vibration. Not sure why. Is it on oscillate? No. It's not locked down. Okay, she's running pretty smooth. Doesn't want to vibrate all over the place. It's a little off, but I really don't feel comfortable bending anything any more than I have to. It's going to be fine. I don't want to bend anything else. I've done a lot of tweaking on this fan, more than I have ever done before. So I think we're ready to just fire it up for the first time and see what happens. Okay, here we go. No hitting at all. Notice how there's plenty of space for that massive Vortalex blade. It's a little noisy, but we do alright. That does vibrate a little bit. We're going to take care of that just by tweaking on the fasteners a little bit. Now, you don't want to, so you want to be careful when you're tweaking aluminum head badge fasteners. Number one, you don't want to damage the aluminum. So what you want to do is some scrap felt in the garbage can. Okay. What we're going to do is we're going to take our channel locks, close them up a little bit, put some felt in the jaws of the channel locks, like that. Lightly, ever so gently, squeeze the tabs closed a little better so that it doesn't vibrate anymore. That's it. Okay, that's it. Just so that it don't vibrate anymore. Okay, now. Okay, so we're not done yet. Oh, we still need to do some stuff. So I ran the fan last night, and well, a couple of things are driving me insane. One of the biggest problems that I'm finding is that when it's running, usually on high speed, it develops an annoying buzz. Hear it? There we go. Well, it's not doing it now. Once it warms up, I assure you it will. Now, what happens is the windings in the motor or the stator are loose. They're able to move around, and they probably shouldn't. So I have an idea as to how I'm going to fix this. I'm going to epoxy them in place using the self-mix epoxy. I use this stuff on a couple of other projects, and it is balls-tastic. This is Loctite Epoxy Instant Mix. This is the less expensive version. This is good for up to 2,500 pounds. It's a 1-minute set time, and I've used it on a couple of things, and it's just the best. So what we're going to do is we're going to take the motor back apart again, and we're going to try to do something about that. I'm also going to take another look at the bearings and make sure that they're getting lubricated, that they're nice and clean. One thing I forgot to do was actually clean the bearings properly. I did not do that, and I aim to fix that now. Okay, to start off, we're going to make sure that this one gets most of the grease, or the epoxy. I'm going to inject some epoxy into this pocket here, and this won't hurt anything. It's just going to solve a problem. That's all it's going to do. We're going to put some in here. We're going to throw some up in here. Throw some in here. This has a shorter set time, which is a good thing. The only time this is ever going to be an issue is if this fan ever needs to be completely rewired, or if the coils ever need repair. At that point, it's pretty much, you know, there's no way you're going to fix it at that point. This stuff does smell pretty bad, I will admit. It's actually quite noxious. So I'm going to go and turn this around. Alright, I got a flashlight in my mouth, see? And, oh, I can fly up. Alright, so you put that in. Okay. Now, if any of it dips down, you're going to have to scrape it off.
Cause it's gonna be bad. Oh shit, I'm getting on the fucking countertop. Son of a bitch. And the fucking flashlight is so fucked up. God damn it. Alright, let's try that again. That's good. Okay. I can't get the back. Alright. God damn it all.
High speed. And me likey. So I think I can put the grill back on. Call it done. Also improve the spin down. Spins down quite nicely. I was able to reset that front bearing so that it doesn't put any pressure against the shaft. I think it was a little misaligned before, so I think we're good to go.